Awesome. Well, welcome everyone. Welcome to today's meetup. All of you here. We're here today to hear from Arno and Alex. I will let them both introduce themselves about their background. And they're going to talk to us about the US 2020 elections, Web Monitor, about the visual analytics dashboard that was powered by webLyzard technology and Elasticsearch. We will take all the questions at the end because it's easier for the speakers. You can put them in the chat function or in the Q&A. And we're also recording this meetup, so you will get the chance to rewatch it afterwards. And yeah, that's all from me. Go ahead, Arno.
Thank you very much, and good afternoon, good evening, everyone. So it's a pleasure to be here and use the next half hour or so to tell you a bit about our recent projects and applications of Elasticsearch. We'll be two presenters today. My name is Arno Schall. I'm the managing partner of webLyzard technology, and I'm also a professor of information systems at Modul University Vienna. And I'm joined by Alexander Hupmann-Heidvogel, who is a co-founder and is responsible for our front-end development team, including the dashboard and visual analytics components that I'm also going to present live today. The application is our US election 2020 web monitor. You can see the address of both the dashboard as well as our landing page with a bit of additional background information here on this slide. And also will make available the slides of this presentation under the URL that you see below after the meeting. So before I go into details about the results and what we can see about the US election, just one slide that shows you the technological fundament of our platform. It's a full content processing cycle that starts in the upper left corner with the data ingestion components. That means we run our own web crawler, we go to the APIs of the various social media platforms. There's a lot of pre-processing, filtering, deduplication, boilerplate removal at work. And then, which is a core part of the architecture, comes the analytical phase, the knowledge extraction phase, where we extract both facts and opinion from all the documents that we're gathering. As you can imagine, in a case like the US election, we're talking about hundreds of millions of documents. And we have our own opinion mining stack, sentiment analysis, and a knowledge graph that allows us to structure that knowledge. And there is also already a lot of Elasticsearch at work here, because while the knowledge graph in its original is stored in a triple store for performance reason and to distribute it, it's also cached in our Elasticsearch cluster. Through all this analytical phase, what we can do is we annotate each document. So every tweet, every news media article that we ingest is fully annotated by sentiment. We annotate it with keyword labels. We create automated summaries, identify named entities as persons, organizations, and locations that are being referenced in the text. And then we provide various visual means to access this content. One system, which I'm going to show live today as well, is our visual analytics dashboard. That's the flagship application with a lot of bundled features, but there are also access mechanisms of lower complexity. There are PDF reports, there's a mobile app. So there are various ways where users of the platform can make use of this information. And yeah, our system has a long tradition, and it boils down to how can we measure social perceptions based on the public debate. So how far can we take automated methods to understand who are the opinion leaders, who is driving the debate, who is triggering trends, maybe who is also spreading misinformation. And this overview slide shows the various ways you can measure such social perception and also measure the success of communications. And I'll start with the two simplest measures, which is share of voice and sentiment. So sentiment means if a candidate or a topic is mentioned in a positive or negative context. And yes, as I've mentioned, our system has a very long tradition. We actually, first time we ran an US election monitor was already back in 2004. You see an ancient screenshot of the system, which was then George Bush versus John Kerry. We repeated that in 2008. You can see from this little screenshot, it got a bit more advanced, but it was still a rather static system, which was presenting statistics that aggregated pre-computed variables. And soon after that, or between this version and next, we actually switched first to Lucene and then in 2014 to Elasticsearch. And this was really a game changer for us. I'm not saying this because today is Elastic Meetup, but it really was because we actually went from a system that was showing pre-computed statistics. We were able to convert it into a real-time content exploration and visualization system. And this was the 2016 version where we had the race from Donald Trump versus Hillary Clinton. And then this is actually a screenshot of the system that I'm going to show today. So you see it has been constantly evolved. It has got a lot of new features. And that's actually also in designing this dashboard an ongoing challenge that we are facing, being able to add functionality to the system without making it overwhelming. Because what you can see on this screenshot, it's a multiple coordinated view display. That means it's not just only one visualization at a time, but one of the strengths of the system is actually being able to synchronize all these visualizations. So there's a lot of interactive features, which you'll see in the live demo. And when you change or interact with the data in one view, all the rest is synchronized in real time. In terms of what we have defined here, so there are in the bookmark section in the upper left corner, there are predefined topics. And to monitor the election, we actually have, of course, defined the presidential candidates and their running mates. And we have it defined in a very specific manner. We were always looking for mentions of one candidate, but none of the others. Because every time you do election monitoring, you realize, well, there's a lot of what they call horse race coverage. That means there's a lot of coverage that just talks about both candidates and who is leading the race, but they're less talking about the issues, what they stand for, what they represent. And to extract this type of information, that means we have 14,753 documents that mention Joe Biden and none of the other candidates. So that's maybe important to remember when you interpret some of these visualizations. Speaking of which, I'll show you a few of the examples. And Alexander will actually then, in the next part of the presentation, tell you a little bit about how these are being created, what type of Elasticsearch queries we are using. But one of the simpler ones is a tag cloud. We always use color coding. Color coding is used in a dashboard to represent all types of metadata. In this case, it's this automated classification into the coverage of the candidates and their running mates. And that means you see the top association with each of them. So dark red are associations with Donald Trump, Joe Biden are the blue associations. And the analysis here was done between September and October 2020 based on 220,000 online articles. That's a newer one. This is actually covering the whole period until shortly after the election, until November 9. The geographic map shows all the locations that are referenced together with one of these persons. And we also have interactive tooltips that not only present additional information and previews, but also provide Boolean search operators where you can drill down in the coverage and restrict the results to a certain subset of the information space. That's a scatter plot that projects the sources. So we're looking at the sources now from English language news and Twitter. And the vertical axis is sentiment. So the higher up, the more positive. The more on the right, the more frequently the candidates were mentioned. And it's already quite obvious from this analysis that the average sentiment towards Joe Biden was more positive. Although, and this is, I'm going to talk about the end, sentiment should not be used as a success metric. So it's not always like if you're more positive, that means you're more successful in your communications. But it's still, nevertheless, an interesting pattern here to observe. And then we also have in this next slide a projection between early October and November 9 again. And it is based on Twitter coverage. And we have frequency in the upper chart and sentiment in the lower chart. And these vertical lines just highlight certain events here. So we have the TV debates, the one town hall, and then another TV debate. And it is quite obvious from here that, of course, the candidates themselves had way more attention. What's actually very different, this is when we've done this 4 years ago in 2016, where Trump had an overwhelming percentage of the coverage. It's actually interesting that especially after the debates, there was more discussions on Joe Biden than on Donald Trump. And we see the running mates had just one peak here, which was immediately after the TV debate. And we also see that, especially given that he is or was the vice president, there was very little coverage on Mike Pence, only after TV debate. And a lot of this peak was actually, if you remember, there was a fly sitting on his head for about 2 minutes, and that made a lot of attention in social media. And this is actually what this one peak here shows. And then after the election, of course, Joe Biden winning the election, the sentiment goes up very rapidly because he is declared the winner, and that is showing up clearly as a trend in the coverage. That's one of our most computationally intensive applications that puts quite a bit of stress on our Elastic cluster if a lot of them run in parallel. That's our real-time story detection. So that means from also very large samples, our goal was to cluster the coverage in real time. Of course, there needs to be a lot of optimization and approximations because you cannot do like a proper k-means or other types of clustering. And it shows on a timeline what were the top associations, the stories, when did they emerge, how dominant was this story, how long did it last, and what were the keywords of one particular story. And this is also now, this is the story graph for Donald Trump, and this is the story graph for Joe Biden. And it's the visual representation of this story view on the right side, and this story view on the right side is what you know from other news aggregators. It shows one leading document and a few related documents. And what you see on the left is just a visual representation of this real-time clustering of documents. So I'm trying now to switch to my browser and show you a live demo. So this is the landing page that you have already seen on the first slide. And I'm also here. There will be another link with a download option for the slides. And this leads then to the live dashboard. So this is what I'm using now. I'm not even logged in. So this is the fully anonymous version, so everyone can access this online. Having said that, we do have a login. So there are some additional features. You, as a registered user, you can create your own bookmarks. You can create email alerts. So we got our contact details on the last slide. So if you'd like to explore more of the system, we are more than happy to create a login for you as well. So just to quickly go through what we can see here, the visualizations themselves you have already seen. So I would like to drill down a bit on a specific topic. And one specific topic, which is, as you will know, climate change, is high on the agenda of Joe Biden. And let's use this topic to see how we can use this for a real-time exploration of the content space. So I have now 3,800 documents that stem from news media. I could now extend this as well with various sources. I could, for example, here add other English sources as well. And I see that the climate change coverage, the running mates are hardly mentioned, so let's deactivate them for a second. And all our visualizations you can magnify as well, so then you get a bit more detail. And when you mouse over the stream graph, you can already see that everything is tightly coupled, because when you mouse over, the story view below automatically assumes the one story that you're currently investigating. If you look now at the tech cloud, you've already seen this is now not a general tech cloud, but this is only the associations with Biden and Trump in documents that also mention climate change. You can now switch from the story graph also to a trend chart with various moving average calculations to determine what type of trends I'm looking for. And down here is our content area. There are various ways you can represent the results of the query. So it takes these 3,900 documents up here that mention climate change, looks how many of them are also mentioning Joe Biden and Donald Trump, and the result you see down here. So we have this normal list of matching documents. It is possible to drill down on the sentence level now to see all the matching terms as a list with the matching terms in the center. There is the possibility to take all these threads and visualize them as a word tree. Also activate sentiment color coding here. And you can also switch between the candidates here. So as you can see from these examples, everything is real time. There's nothing pre-computed. We can do this on pretty much any search term up here. I don't have today the time to go into this, but if you go into advanced filter, you see it doesn't have to be a simple search term, but we have a lot of search options that allow you to define various types of metadata from the source or target location, entities, URL restrictions, reach, length of the text. You can use regular expressions. So there's a lot of things you can do when you define this context filter up here, or also define one of the bookmarks. And in addition to presenting the results in various ways on document, sentence, or word tree level, it's also possible to take a look at the sources. So who was publishing articles on Biden or Trump that mention climate change? And we see Reuters is leading with 22 here. And we're always, by the way, we're talking about the last 2 weeks from January 7 to January 21. And we have little keywords underneath the URL. That's the top associations of that source with the search term. We have the reach of the source, which is just a proxy for the average traffic to receive on the websites. And the color coding is used in the impact section as well. That means we can see that some sources, like The Guardian, actually had more articles on Trump than Biden, and other sources like ABC News had only 6 articles, and they all mentioned only Joe Biden. This is also possible to show this as a scatter plot, which you have seen in one of the previous slides, or you can switch to the entity view. Now, this is interesting. I mentioned in the very early slide that we have a knowledge graph, and it's cached also in Elasticsearch. And this now in real time extracts knowledge from this knowledge graph. It looks for all the persons that were mentioned together with climate change, and also how often they were and what is associated with each of these persons. We can also switch this to locations, for example. So all the entities that are being stored in the knowledge graph can be used here to classify the search results. And again, we got a tech cloud here where we can then project all the persons in terms of frequency and sentiment, again, positive and negative. That's just one way we can classify the coverage. There is another widget down here, metadata. And if I deselect that, I can now look at these 3,900 documents on climate change from different angles. I can compare them by source news versus other online sources. Let's just go back to the other view here. Or I can color code it by sentiment, show the positive and negative associations. I can color code it by recency. That means now the warmer color presenting the newer topics. So if I'm magnifying the tech cloud, that means the warmer the color, the newer, so the closer to the 21st of January it was, and the older the color, the closer it was to the 7th of January. Maybe a word on the geographic map. We have different locations that we can visualize. So we have now still our query for climate change. And if I'm activating the United States and the UK, for example, to just compare two, I'm seeing two things. These markers show which are the locations that are mentioned together with climate change. And if I activate the source location, I also see where this information comes from. So Australia and Canada shows a very good picture of where does information come from, which locations are being talked about. And when you zoom in one of these visualizations, automatically more detail is being loaded. And I've already mentioned our tooltips. They work in all these visualizations with the Boolean options. So if I want to know what's being associated with Frankfurt or with Amsterdam or with Berlin, I just mouse over it. And this tooltip works almost everywhere. You can extract only the coverage from the Independent, 130 articles, or the 107 articles from the Guardian. You can go to the tech cloud and pick one term. I have Trudeau here. Let's assume I'm not interested in this analysis on Trudeau. You just click on this and exclude, and you rerun the analysis, and you're just excluding all documents that mention Trudeau. If I want to do a by country analysis, I can magnify the trend chart. And if I now would like to see more European countries, I can look for Ireland. It's only English language at the moment. Well, we don't have that many here. But we can increase the coverage. We just go back all the way to the 1st of October, also showing you a little bit of the throughput, and everything is real time. Now we have 32,000 documents. And of course, we have much more coverage here to choose from. So let's set the UK. Germany. And now we get the specific association with climate change from each of the countries that we're activating here. And this also concludes my short live demo. And as already mentioned before, I'm now passing over the presentation to Alexander, who is going to tell a little bit about what's working behind the scenes, and what type of aggregations, etc., we're running to obtain these visualizations.
So, Arno, give me a thumbs up if my unmute worked.
Yes, it did.
Yeah. Okay, awesome. So Arno briefly mentioned that we're doing this for quite a while already. So we started with a Postgres database where we had pre-computed data sets. Also the time series were pre-computed. We then started improving on that, used tsearch 2 to speed up the full text searches within Postgres. We're hitting the limits. So we moved the content from Postgres into a full text index based on Apache Lucene directly. So we're writing Lucene indices. This was working for a while. Then, of course, we were hitting the limits again, limited to just one machine where these indices were stored on. So we had a look at Elasticsearch. Our first prototype was actually still with 0.9, and we adopted then 1.0 in early 2014 and have been working with Elastic since then. our current cluster evolved over time. It's currently based on 5 physical machines. Within the next month or so, going to be the 7, which are dual socket Xeon machines. We try to have a balance here between CPU and I/O processing available on each of these machines. Storage is done on currently 3 M2 Samsung SSDs in each of these machines as a striped array. So we have 3 terabytes per machine in raw storage. To actually use that to its full potential and to avoid any overly large virtual machines, in Java, we're actually running multiple Elasticsearch nodes per machine. So that's currently 4 data nodes, which serve all the data and hold the actual Lucene instances below. Each of these machines has a master node, and each of these machines has one coordinating only node, which is also then accessible from the outside to talk into the cluster. So these are 5 identical machines. Any one of these can go down. All of the services connected to the cluster are connecting to all 5 of them. So there's an automated failover, which of course also makes a rolling upgrade quite convenient. Those are based on the official Elastic Docker containers. All these machines are grouped together in a Docker Swarm overlay network so that they can talk to each other. The actual discovery of the individual virtual Elasticsearch nodes is done through DNS. So adding and removing nodes here is really quite convenient. So I think, Arno, it was your first slide when you talked about all the ingestion we're doing and where the data is coming from. So I'm not going to go into details how we get the data, but assume we have all the documents, be it Twitter content, normal web content, Facebook, or whatever you want to push in there. Once all this backend processing with all the enrichment is finished, we want to push the data into Elasticsearch. So this is currently done in a custom Java-based component based on Vertex. We're reading the data that is already enriched from CockroachDB, also still supporting Postgres for the legacy data. So we're in the process of switching everything to Cockroach. This indexing component now takes this normalized data, enriches it additionally, so it ties into, as Arno mentioned, the triple store to get in additional information to each of the documents. So what Arno hasn't shown are our cross-lingual features. So we do automated translations of, for example, keywords and named entities, which are brought in here, as well as additional things like geographic coordinates for the entities you saw based on both geonames and Wikidata. This component then decides how to split these documents into the various indexes. So we're currently maintaining a mapping of one source, so either social media, news media, custom sources per language and per month. So we're creating a new index slice per month, which also allows us to naturally limit the number of indices and shards we're hitting per query, since we're naturally chronologically based. So you're querying the last month, the last 2 months, or just the last 2 weeks. And there we have a natural split how many indices and shards we're hitting with our queries and aggregations. So you already saw the geomap. That's a fairly straightforward implementation. So here we're doing a normal GeoHashGrid aggregation on the extracted locations. Previously, we just had one location per document, which was decided upon that this is the main location of the document. Now we're also visualizing all the available locations that are detected within a document. The precision in the dropdown is selectable and auto-adjusts depending on zoom level. So you've seen if you zoom into a certain region, of course, this aggregation is recalculated and you get more detailed grid there. And as a first aggregation that is also visible, we can aggregate, for example, the average document sentiment for one of these hash grid locations. And additionally, sometimes you see that depending on how the hash grid is stored or organized, we're trying then to pick one main location from within that hash grid to actually have the dot on, for example, the city that's inside that hash grid. The word tree you've seen here, each document in our index stores both the full text of the document as well as nested objects, each sentence. So we can also do an inner hits query in Elastic to actually get the individual sentences that are matching on a specific query or parts of the query. So of course, we're only interested in those sentences that match the query. And the benefit here is we're maintaining the document level sorting. So we're still getting, for example, the top 50 documents or the top 100 documents matching the query. And out of those, we're extracting the matching sentences and then aggregating them in this tree visualization. And the last example, and Arno mentioned already, this is the computationally most expensive one, is the real-time story clustering. So here we are having always a larger time frame. So we are aggregating, we're applying here a date histogram aggregation over the time interval, and then we're extracting the top keywords per time slice. And then there's a second level of aggregation running here as well. So for each of these extracted keywords per time slice, we're again calculating the top associations to that specific keyword. So for example, we're getting 5 keywords for a specific day, and for each of these 5 keywords, we're again getting the top 5 keywords that are associated to this keyword within that day. And this allows us to convert that into a graph. So we're connecting keywords in subsequent time spans. So if one keyword spans multiple days, we can connect them in a graph. And this gives us a graph layout where we can run a community detection algorithm on that. And that's currently based on the Laverne method, where we try or having a look at the modularity. So we're trying to cluster keywords together that appear together and say, okay, these keywords form a story. And once we have these stories detected, we can again then run a histogram aggregation for this specific story over time to actually see the stream graph Arno has shown, where you see how that story evolves over time and how many documents are part of that story over time. So this is Arno showed that showed it to you for about 5,000 documents. If you run that on 200 million documents, you have to wait a bit longer, but it still performs really great, even if in these large data sets. So this was a quick high-level overview of what's behind here. If you saw anything in the presentation or in the live dashboard, if you're viewing it and have any questions about how specific things are done, just give me a heads up in the chat and I'm happy to answer any questions then at the end of the talk in detail.
Okay, thank you, Alexander. And looking at the time, I'll try to conclude briefly so that we have time actually for these questions. So I'm going back now to this initial slide where I showed the overview of the different ways we can measure social perceptions. And so far, we really only have talked about the first two, share of voice and sentiment. But in many applications, both for political communication, but also for sustainability communication or brand communication, brand reputation, there is usually an interest in a much finer grained assessment of what type of emotions are being mentioned together with one's brand. So there is another component that we have developed, which is a radar chart, the brand reputation radar, which in this example shows the standard brand personality dimensions of ACAR. For those of you with a marketing background, we just have added sustainability here. The nice thing about running all this through an Elasticsearch index is that we can do this in real time. So you can compare any bookmarks, any brands, and you can also add the dimensions all in real time during a workshop, which is great when you want to jointly define these dimensions. For example, you're in a workshop with a brand and you want to brainstorm, what should this brand be associated with? So that would be custom dimensions. With the same principle, we can also map all the content items that we're ingesting to standard emotions. So this is Plutchik's Wheel of Emotion. It's a well-known established framework that has 8 major emotions like fear and joy and others, and then each of them in 3 different degrees. The more in the middle, the stronger the emotion is. And then last but not least, we have also developed our own metric, which is called Wisdom, the webLyzard stakeholder dialogue and opinion model, where we've done a rather long collaboration with NOAA, with the US Climate Change Agency. And for them, it was always of interest if they are successful with their communications. And especially in that work, we realized what I mentioned initially, that sentiment is not a very good measure of communication success, because you can imagine NOAA is the US Climate Change Agency. They run the satellites that report on hurricanes. And so they're always in the negative because their mission is actually to report about mostly negative issues. So sentiment is not a good indicator if they're successful with that. So we developed this method where we're asking the organization, what do you actually want to be associated with? What are your desired associations? And what would you rather like to avoid being associated with? And we can measure this now in real time. So this is the darker red and the darker green are now the desired and undesired. And the blue one, we can also bring in audience metrics. In that case, this would be page views and visits from the server log files. So you get a nice comprehensive story about what's happening. You see in blue what's happening on your website, and you also see the sentiment, but also how you're doing in terms of your desired and undesired associations. That already brings me close to the end of my talk. To acknowledge our organization who are funding the continuous development of our platform, but also to let you a little bit know as part of which research ideas and research roadmaps we are developing this. So you see most of our funding stems from the European Commission, from the Horizon 2020 program. We have one project which is called ReTV, which is ending this March, which is looking into how can we measure and improve the impact of communications and the repurposing of content assets. We have 2 national projects which are called Epoch and Gentio, where we look at the predictive capabilities of our platform. Prediction in that case means you saw in the presentation, we presented data from today into the past, the last week, the last month, the last year. In these 2 projects, we turn it around and we are not looking actually when the document was published, but we are trying already to find references to future events. So let's say yesterday's inauguration, people were already talking about the inauguration 3 weeks ago. So it was completely known by just analyzing the public debate that there will be an inauguration yesterday. And by doing that with millions of documents, we get a very good overview of what's going to happen in the next 2, 3, 6 months. And you can use this information, of course, to guide your communication initiatives. We have one project which is called Evolve, which is a big data project, which helps us to continuously improve the scalability of our methods. And we have another one, which is Indices, which looks at digital culture and cultural heritage and what we can learn about that sector through our analysis. This is already my last slide. I've mentioned the contact details. We, of course, are always interested in new ideas for project, in new collaboration. So if you have an idea, please feel free to contact us. And yes, thank you for your attention. I'm now switching back to the other screen, and I look forward to your questions.